All right, we are on to lesson 7 now over solving something called systems of equations, and we're going to do that by graphing. So I decided that systems of equations is such a big unit that we're going to do 2 lessons over it. So today we're going to just do the graphing portion of it, and then in our next lesson we're going to cover the algebraic methods of solving systems. So let's first look at the definition of a system of equations. There's a lot of definitions, but basically a system of equations is when you're working with 2 or more equations that have the same variables, okay? So in Algebra 1, you're going to deal with just 2 equations at a time, but when you make it to Algebra 2, you guys will do problems that involve 3 equations. So it definitely builds, so it's a really important unit because you have to have this foundation before you can do the 3 equation ones. Okay, so if you want, go ahead and fill this in right here, this definition, and then if you notice in these 3 boxes, I just drew a quick little XY coordinate plane if you want to jot that down, and then we'll make it down here in just a minute, but I just wanted to show you real quick. This is a system of equations, okay, so it's just giving you 2 equations to work with at the same time, okay, so let's dive into this up here. So how do you find, or what exactly is a solution to a system? Well, graphically, which is what we're going to do today, it's just where the point where the 2 lines intersect. Okay, let's fill that in. The point where the 2 lines intersect. So you're basically just going to draw 2 lines and see where they cross each other, and that point is your answer. And that's why they put this here, this x comma y, because a coordinate is actually going to be your answer to the problem. All right, and then algebraically, we'll fill this in, but this will make more sense when we do it in our next lesson. The solution, if you're doing it algebraically, is the point xy that makes both equations true. But don't worry about that right now because we'll deal with that in the next lesson. Okay, there are 3 different types of solutions that you can have here. One of them is you can have, if you look down here, you can have 1 solution, you can have no solution, or you can have infinite solutions. Let me show you what that would look like on a graph. The first one is really the most common, having 1 solution. That's usually what you're going to get. And what that looks like is if I just draw any 2 lines that intersect somewhere, just like that. Let me draw my arrows. Just any 2 random lines that intersect, that intersection point is their solution, and you'll just get 1 of them. And that solution, I guess we could add that right here, your answer will be a coordinate, like the x comma y, the ordered pair that is that point. Okay, another instance here is you could have no solution. So you could think about like, well, what would that look like? Well, that would be if the 2 lines never intersect. Okay, so we would be working with parallel lines in this case. So let's see if we can draw a pair of parallel lines the best we can. So we'll say these 2 lines are parallel, which means they will never intersect, which means we have no solution, no intersection point. Now, there's some room underneath no solution. I was going to show you, your teacher will probably want you to write no solution as your answer, but there is a symbol that represents no solution, and it's almost like a circle or a 0 with like a line through it, something like that, okay? But your teacher would probably be wanting you to write no solution. Okay, and then our third case that we'll have is something called infinite solutions. So this would be where you graph your 2 lines and they're intersecting at every single point forever and ever. So if you think about what that might look like, let's draw a line. Okay. Oh, that was relatively straight and I didn't use my tool. Cool. Okay. Here's a line, and then let's say you go to draw your other line and this happens. That's where your other line is. It's like right on top of that one. Essentially, they are the exact same line, okay? So if you're dealing with the same line, we say infinite solutions because they literally intersect each other at every single point in both directions forever and ever. And there is a symbol for infinity, right? You could draw the infinity symbol like that. But again, your teacher probably does want you to write infinite solutions. Okay, so you know the types of solutions we're going to have. Let's actually dive into solving them. And I think this will go well for you because we have done a lot of graphing already, but this does throw it all together. So you do have to remember how to do, your rise over run, your slope, which I know can be tricky. So if you're still struggling with that, that's okay. I would expect that at this point. You've learned a lot. And then getting equations into slope-intercept form, that could be tricky too. We just went over that. So this combines a lot of different things. But overall, it's not too terribly hard, especially if you feel confident in graphing. So here are the 3 steps here. If you want to pause this and write it down, step number 1 is always get your equations into slope-intercept form. Okay, that's that y equals mx plus b form, if you don't remember. I'll put that above it here. Let's do this. Y equals mx plus b. And really, if you're like, well, how do I know if it's in that form? If the y is all by itself on one side and everything is on the other side of the equal sign, then you're good. So if you glance over number 1, for instance, both of the y's are by themselves. So these are already in slope-intercept form. So you don't even have to deal with step number 1. And actually, same with number 2. So those will be our easiest ones. Okay, step number 2 is simply graph both lines, which we've had quite a bit of practice graphing lines. And then step 3, identify the intersection point, and that's where you will write your solution. So let's try number 1. Okay, let's start with, and I'm gonna pick 2 colors to draw these in. You don't have to do that. It's totally fine if you just use pencil or pen and do it all the same color. But I'm gonna do this top one in blue. So let's go ahead and graph that line, which I know I start with my y-intercept of -8. So I'm going to count down 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to make my first point. And then we look at our slope. So our slope, it's just an x, right? So our slope would be the number in front of x, which is technically a 1. And if you want to write 1 as a fraction, that would just be 1 over 1. Okay, so, and they're both positive, so that just means we go up 1, right 1, and make a point. And we keep doing that. Up 1, right 1, make a point. And you can see the points are going to go like this. And I do highly recommend graphing as many points as possible, okay? The slope of 1 is easy, but it's a little tedious because you have to graph so many points. And then make sure you graph them in this direction as well. And you can tell where those are going to be just visually, but the way you reverse the slope, instead of up 1, right 1, to get more points the other direction, you go down 1, left 1, and make a point. Down 1, left 1, make a point. Okay, and then, of course, we draw our line through it. Now, I did have some kids ask, do I do a solid or a dotted line? Which makes sense because we just came off that section over inequalities where we had to decide that. So, y'all, whenever you have equal signs in your problem, it's always just straight lines. The only time you have to make that decision of solid or dotted is when you're dealing with less than or greater than or equal to, signs like that. Those are called inequalities, but that's not what we're dealing with here. So let's go ahead and graph that line the best you can through it. And sometimes it's hard to get your line exactly through every point, which is why it's important to have actual points dotted, highlighted, just like I have here, as many as you can. Okay. Let's do this one. We'll go green. And let's start at our +1 y-intercept. That would be right here. Then we have a slope of -2, which if you want to write that out to the side, that's just the number -2 over 1. Sometimes it's helpful to write the whole number slopes as fractions so you can clearly see what's my rise and what's my run on top and bottom. Okay, so -2 is the rise, and it's negative. So instead of going up 2 for my rise, I go down 2 for my rise. So I'm going to go down 2, and then I always go to the right 1. And then let's keep repeating that. So down 2, right 1, down 2, right 1, which, boom, I can see already where they're intersecting. If you've graphed them correctly, you'll see ooh, I've got 2 dots right on top of each other here. Let's keep going. Down 2 over 1. down to over 1, and that's all I can fit that direction. I like to get as many points this way too because it's really easy and it helps me make my straight line. So I'm going to reverse it and now go up to left 1, up to left 1, up to left 1, up to left 1. Okay, that's all I can get, and I'm going to draw my line through it. Here we go. Okay, and so step number 3 after we've graphed them is just identify your intersection point. So I can clearly see it's right here, but you need to write out that exact coordinate, okay? So remember how we do coordinates, you start from the origin, and be careful because it's not like rise over run. In fact, it's the opposite of rise over run, so try not to mix those up. I know that's tricky, but when you graph coordinates, you always go like left and right first and then up and down. So we would go over how many? 1, 2, 3, over 3 in the positive x direction, so positive 3, and then down 1, 2, 3, 4, 5. So negative 5 since we went down. So 3, 5. That's our final solution of that system. Okay, very good. Let's try another one. Okay, and they're both in slope-intercept form, so we are ready to graph. Let's do this top one in blue. We will start at positive 9, which I think this is a 10 by 10. So instead of up here at 10, I'll just go down 1. This should be 9. All right, and then our slope is 1 over 2. Okay, so I go up 1, right 2, and make a point. And I can't make any more, so remember how to reverse it. Instead of up and to the right, I can go down and to the left to get more points in the other direction. Down 1, 2 to the left. Down 1 over 2, down 1 over 2, down 1 over 2. All right, once you get all those points, let's draw the line. Okay, good. Let's go ahead and graph this bottom one. So we're going to start at 6 now. So 1, 2, 3, 4, 5, 6. Okay, and I have a slope of, this would be negative 1. And if you want to write that out to the side as a fraction, negative 1, you would just put it over 1. So keep in mind what that means. I know everyone struggles with the negatives and stuff like that, but the top is your rise. If it's positive, you go up. If it's negative, you go down. The bottom one, the way I teach it, you always go to the right until you completely reverse them to go in the other direction. Okay, that's a different thing. So starting here, I'm going to go down 1, right 1, make a point. Down 1, right 1, make another point. And you can see how the points are just going to go like this forever and ever this way. Okay, get as many as possible, but we really want to get the points this way because we want to see where the lines intersect. So to reverse it, instead of down 1, right 1, we go up 1, left 1. Up 1, left 1, boom, I land on a point, which is always good. I'm going to keep going. And there's my line. Okay, let's draw that line. And we can clearly see our intersection point right here. So now it's just carefully counting the units to figure out where that is. So we start from our origin. We do our side to side first. So it'd be over 2 in the left negative direction. So it's a negative 2. And then I go up 1, 2, 3, 4, 5, 6, 7, 8. So, and that's up in the positive y direction. So that's a positive 8. So negative 2, positive 8. And you can now solve systems of equations by graphing. Let's see the other side here. So this lesson, I intended it to pretty much end right here. All of the rest of this is bonus content, which you are so welcome to do. But I want to make sure you can get these top 4 graphs. And if you get those and you're good, move on to the practice. And let me show you real quick the practice sheet. Oh, this is definitely the key, which I will send you. Let me clear it though. Actually, did I put that key? Yeah, okay. Let me clear this just so I can show you. The practice sheet, I really want you to focus on these top 4, Okay, I split it into 2 sections here, and I only did 4 because they do take a while to solve and graph. These bottom 4 are all bonus, so if you make it to that, go for it. But the video for the practice is like over 30 minutes because I cover both of these. So if you want to just do like the first 15-ish minutes, however long it is, that's totally fine just to do that top part. Okay, let's finish up 3 and 4. And then if you want to hang around for the bonus, you can. Okay, so 3 and 4 will be a little bit more challenging because those are not in slope-intercept form, right? If you look at the equations, y is not by itself. It's got like this negative 3x with it. Same with this one down here. So let's handle that first. I'm going to put a blue star next to this one, and I'm going to bring that one down here. Negative 3x plus y equals 8. And we've done this in a couple of lessons now, but I know it can be tricky. So try to follow along here. We want to get the y by itself. And we've learned that to do that, you want to first move the entire x term to the other side. So how do you take a negative 3x and move it completely over? Well, you do that by adding 3x to both sides. So those 3x's just cancel out, and you're left with just this positive y, which you don't have to write the plus sign, it's implied. I'm going to bring it over to the left a little so we have room. So we get y equals, and then on this side you could write 8 plus 3x, but remember if it's in true slope-intercept form, the x term will always be written first. So I would write it as 3x plus 8. And you just have to be mindful of their signs. 8 is positive, the 3x we're adding, so they're both positive. Okay, great, we got that one in slope-intercept form. We might as well do the same with the second one. I don't think either of these are too bad actually. So negative x plus y equals negative 2. Okay, same concept here. You want the x term to the other side. So we would do that by adding x to both sides, just like the other one. Then we would get y equals, now on this side you have a positive x and a negative 2. So I would write x minus 2. And there's our equation. You know you're done when your y is all by itself on that side and everything's on the other side. Okay, let's go ahead and graph this blue one. I'm going to start at 8. So if this is 10 up here, I'm going to go down 2. This has to be 8. Make it a little easier. Okay, I have a slope of 3. So keep in mind that's like the number 3 over 1, and they're both positive. So that means you do go up 3 over 1, which, yeah, this does go off the graph, but you could kind of mark like where it would be off the graph. It's not too far off. Or you can completely reverse it. Instead of up 3, right 1, we're going to go down 3, left 1. And you can tell like the trajectory of that line, it should go this direction, okay? So you can use a little bit of logic. If you get stuck with slope, you can use logic to figure out where the point goes. Obviously, I'm not going to go down 3 and right 1 because then like this would be like not a straight line, right? Okay, so from here, down 3, left 1, make a point, and keep going with that. Down 3, left 1, make another point. Do as many as you can. 1, 2, 3, 1, 2, 3, 1. Okay, so I get points all the way down my page. And then let's draw our straight line through this. Okay, let's graph the green one. Well, green for me, whatever it is for you, which I have boxed down here. I'm going to start at negative 2. So down 2, make a point. And then from there, I have a slope of 1, which we talked about before. That just means we're going to go up 1, right 1. Up 1, right 1. All in the positive direction. So I can get a whole bunch of points this way. And I can do the opposite, go down 1, left 1 to get more points this direction. And hopefully we cross our line at some point. Oh, I did right there. You should have like 2 clear coordinates that intersect each other. Y'all see where that is over here? Boom, that's where they landed on each other on mine. Okay, now I'm going to draw that straight line. And then I just want to identify what that intersection point is. So carefully locate it. I do recommend using rulers to draw your lines so it's easier to locate. And now let's count from the origin where that is. Let's see, we go in the negative x direction, so negative 1, 2, 3, 4, 5. And then down in the negative y direction, so negative 5 and then negative 1, 2, 3, 4, 5, 6, 7. So negative 5, negative 7 would be that coordinate. All right, let's try our last one. Now, actually, this isn't too bad because this bottom one is in slope-intercept form, so we just have to get the top one in slope-intercept form. So let's do that real quick. Let me bring it down here. So I know I subtract the x from both sides first. Get rid of that. We're left with 2y equals, now this would give us a negative x plus 4 is how we would write it, because it's the x that's got the minus sign on it. The 4 is a positive 4. And then now we have to do an additional step to get y by itself. We got to get rid of the 2, but we know we divide by 2 to do that. We divide everything by 2. So those 2's cancel. We get y equals. Now if you remember over here, the weird fraction, you want to always pull the x out to the side, and that would technically leave a negative 1 up top. It's like there's a negative 1x. So that would become negative 1 over 2 with the x out to the side, and then this would be plus 2 because 4 divided by 2. Okay, that is in the correct form. Let's go ahead and graph that line first since we're working on it. So I know I'm going to start at positive 2. My slope is negative 1/2. So negative 1 means I'm going to go down 1 and then over 2 to the right. I always go to the right. Down 1 over 2. I'm going to get as many of those as possible. And then I'm going to reverse it to get them this direction. So I'm going to go back to the y-intercept and go up 1, left 2, and keep repeating that. Up 1, left 2, up 1, left 2, up 1, left 2. Okay, now I'm going to connect that line. Thank goodness for my drawing tool. Okay. All right, and let's graph the second one. That one should be pretty easy. It's already in slope-intercept form, so we know it's going to start at 2. Okay, so we've got the same y-intercept, and then if you notice, it actually has the same exact slope, negative 1/2. So we're going to go down 1 over 2, down 1 over 2, and you probably notice what happens here. We graph all of the exact same points. Look closely at the equations, y'all. This equation and the other equation, they are the exact same. So this is going to be one of those cases where the two lines are graphed right on top of each other. So you're really graphing the exact same line. And if you look back at your notes, that means since they cross at every single point, this is infinite solutions. So we can just say infinite. So that one was a little tricky. And I think you're good to stop there and go try those top 4 on the practice sheet. And if you want to come back and finish this, we'll get into this now. But yeah, just see if you can do those ones first. If you master them, definitely try the bonus. Okay, good job, you guys. All right, let's jump into the bonus now. Okay, so you can see the title of this is still solving systems, but now we're looking at linear inequalities, which should be pretty familiar because we did talk about graphing inequalities in our last lesson, okay? But now we're going to be graphing multiple inequalities on the same coordinate plane, which can get a little bit involved and tricky because you've got to worry about, you know, the solid or dotted line situation or the shading, which usually the shading is the trickiest part here. Otherwise, I think this is actually going to be a breeze. I think you'll do just as well as you did with the other section. So either pause this video right now and write all this down, or I'm just going to read through it and then go on to number 1 and show you how to do this. So I defined what a system of linear inequalities is first off up here. And it's very similar to linear equations. It just has the word inequality instead of equation. So it's 2 or more linear inequalities that are graphed together. And then a solution to a system of linear inequalities is a little bit different than a solution to a system of equations. Okay, so for systems of equations, we graph two lines and we find where they intersect, and boom, that's your answer. Now for a system of inequalities, you'll graph two lines, maybe one will be dotted, right? It'll be a little bit different. And where their shaded region overlaps, that shaded region is actually the answer. That is the solution. So the set of points that satisfies both inequalities is your solution. And that's what this says up here. It says the solution is the overlapping region of points that satisfies both inequalities. Okay, so let's jump in and talk about how this works. Now the steps are the same. I didn't rewrite them. It's the same as everything you've done graphing wise. You want to make sure they're first in slope-intercept form, which number 1 and number 2, both of them are, so that's great. And so we're going to go to the next step, which would be just to graph these two inequalities. You may have to look back in your notes from the last lesson to remember how to graph them. Remember, they're very similar in graphing equations, but you decide dotted or solid line, and you decide on the side that you're going to shade. That's the only difference though. So let's go ahead and graph it. We'll do blue for the top one again, and we'll do green for the bottom one. Okay, so top one's blue. I'm going to graph -1 first over here. That's my y-intercept. And then I have a slope of -1 also. Keep in mind that slope, -1, you can put over 1. And hopefully you know by now that that means we go down 1 and to the right 1. So I'm going to do that. I'm going to go down 1, right 1. And I'm going to keep repeating that, down 1, right 1, as far as I can. And then I definitely want more points this direction, so we reverse it and we go up 1, left 1. And we keep repeating that, up 1, left 1. Getting as many points as possible. All right, then we decide if it's going to be a solid or a dotted line. So let's take a look at this right here. Remember, it doesn't have a solid line under it. So it means this one is going to be dotted, which it kind of looks like it is already, but I'm going to go ahead and draw just little like dashed lines through the points I already have. Okay, now here is when, let me draw arrows showing this does go on forever, both directions. So here's where you kind of have options, and you will develop your own process and what works best for you. You can do the shading now, and then the shading on the other one after you graph that, and then where those shadings overlap or intersect, that's your answer. So I will say, if you choose to do the shading right now and as you go, that's totally fine. A lot of people love doing that. I would do it lightly, so I wouldn't be working in colored pencil. Or if you do, just shade it lightly and make sure in the end you darken your final answer, because what's going to happen is, let's take a look at this one. Now this is a y is greater than the line, right? And we know greater than always means shading above the line. So if this is our line, our shading is technically all of this, right? Well, in the end, all of this is probably not going to be in our solution. A part of it will be. So if I were doing it, if I had pencil, I would probably like lightly shade this in pencil, however you want to show that. And then I would erase the unwanted part of it in the end. So I just have like a region left to be shaded. Now we don't know what that region is just yet until we graph the other line. So for now, just to give y'all a visual, I am going to shade this side. So I know as of right now, this whole side is shaded because of the greater than sign. So it's above our line. Okay, let's go ahead and work on the second one here. Let's graph it. So we've got our -5. Let's graph that first. -1, 2, 3, 4, 5. Make a point there. Okay, and then my slope is just +1. So we know that goes up 1 over 1. Up 1 over 1. And we see that they intersect right here. But remember, where they intersect for an inequality is actually not your final answer. It's going to be where the shading overlaps. And then let's go down 1, left 1 to get more points over here. All right, now this will also be a dotted line. This sign also does not have a solid line under it, which by default makes it a dotted line. Draw that through it. Oops. Okay. That works. All right, now let's take a look at the shading on this particular line. So take a look at the sign again. It's y is less than, right? Y is less than this line. Less than means underneath the line. Okay, all of our values underneath the line. So take a look at our green line. Can you guys visualize that underneath it would be this whole region down here? Okay, so I just want you to have a visual of this. You know what, I might as well color this in, and I can do a different color. This might help you visualize this a little bit. Let's change this blue to maybe this like little pink right here. Okay, I'm gonna shade everything that's underneath the green line. So that's like all of this, okay? And can you guys visually tell that the part where the two shadings intersect is this section right here? So what I would end up doing is erasing all of this shading, and darkening this, and that's going to be my final answer. This region represents all of the points that are above this line and also below this one. That region is the only place where both of those things are satisfied. So yeah, let's do that. Let's see if I can do a little precision eraser here and erase some of my shading the best I can. You guys might, if you're using a pencil, you might have to just go in and erase quite a bit on this section. That's just how it goes. Okay, that's probably the best I can do there. And then I would erase some of that. And okay, close enough. And then I would probably just like go back, re-emphasize. I would like darken this whole shaded area. And it doesn't have to be in both of the colors. You can just have one like gray pencil area right here. And you wouldn't write a solution set. This would represent your solution set. Your graph, the overlapped shaded area, is your solution. Okay, hopefully that went well. So let's try a few more. All right, number 2. Let me change. Okay, did we start with blue? Yes, we did. All right, let's try this one again. Or if you want to pause it and try it yourself and then check, go for it. They're both in slope-intercept form, which is ideal. Let's graph the top one. We're starting at +7. 1, 2, 3, 4, 5, 6, 7 is up here. And we have a slope of 1/3, so up 1, right 3, because it's all positive, so up and to the right. 3. Now we can't get any more points that way, so immediately go back to your y-intercept and reverse that, because we know the line goes this way, so it makes sense that we would go down 1, left 3 to get a point on it. I have a lot of kids get confused by that, and they'll try to be like, okay, if I can't go further, maybe I go down 1 and to the right 3. Well, look at this. If you put a point there and you already have this point, that doesn't make much sense for your straight line. It'd have to come back and do that. So you can use some logic here if you just forget how slope works. It's a very logical process too. So it has to go down 1, left 3 for this to form a straight line. All right, dotted or solid line? Well, there's no solid line under it, so I know it's another dotted one. I'll just do the best you can to get the dots on. Okay, and if you want to go ahead and shade now, go for it. Or if you want to try to just shade it all in the end, you can do that. Let's keep doing the method that we did. So I'll do my blue color. Let's see. This is a y is less than that whole line. Okay, so that means that's a lot of shaded area, right? This entire area is technically shaded. You know what? Let me make it a little bit bigger. Okay, all of that is representing our shaded area, which you would want to probably do pretty lightly. I want to get good representation of the shaded area. So nothing above the line, everything below the line. Let's go ahead and graph this second line now. Graph this one in green. And I know I'm going to start at +4. Hopefully I can see through all my blue mess. Okay, 1, 2, 3, 4. There's my point. And then it's a -1 slope. I could write that as -1/1. So that means I go down 1, right 1. Down 1, right 1. Keep doing that. Uh-oh. Get that out of there. Making as many points as I can. And then I want to continue it this direction, so reverse it. Up 1, left 1. Okay, now this one, take a look at this. There is the solid line under the inequality, so we will draw a solid line through this one. All right, and let's deal with our shading now. Let me pick my other color. So this is saying y is greater than or equal to the line. So with the green line, it's got a greater than sign. So let's kind of highlight the green line. Greater than means above it. So we're going to be shading everything up here, right? This whole area would be below that line. So we can see we're going to end up like all this blue is going to end up getting erased because it's below the green line. We want everything that's represented by whatever's underneath this line and also above this one. So you can see how it eliminates that area. Technically, if we're just looking at the green line and it's greater than, it would include this area and all of this, but there's no blue shaded in this one because that's above this line, so you won't actually shade there, or you can, but you'll end up erasing it. So, and I can do that, I'll show you. So technically it is all of this area and then it extends into this. And the only ones where they overlap is gonna be literally this little section right here, okay? So I would go in, I would try to erase the best I can. Let's see if I can carefully do that. It's not going to be perfect here, but I'm going to do my best. Really don't want any of it on this side. Okay, it's probably the best I can do. And I know I don't want any of this pink line up here because there's no blue in this. So I'd get rid of all of it. Okay, that's probably good enough. And then I would just darken your area so it's clear. And this whole shaded area represents our solution set to the inequality. And really what that means is like any point that you pick, any coordinate you pick in this shaded region, if you plugged those points in over here, you would get true statements in the end. Okay, don't worry too much about that, but I just wanted to explain that piece to you. Okay, very good, y'all. If you just wanted to like lightly do the bonus, you could go and do a couple of the other ones right now that are already in slope-intercept form. These bottom two will definitely be the most challenging because they're not in slope-intercept form, okay? This one in particular is like an extra bonus because this top equation we haven't talked much about. You may have learned it last year, or you may not have, so this is why this is extra bonus. Okay, let's get through these and see how we do. Hopefully you follow some of it. Okay, so let's get these both into slope-intercept form. Okay, that's fine. Let's start with the top one. I'm going to rewrite that one down here. X minus 4y is less than or equal to 24. And we know we got to move the x over first, so I'm going to subtract x from both sides. I'll be left with negative 4y is less than or equal to, this would be written as negative x plus 24. And then I want y by itself, so I have to divide everything by negative 4 from here. Now this is the tricky part. There's so many things you have to remember with inequalities. Remember what happens when you divide both sides by a negative? Yes, you've got to flip the sign. So we end up with y is greater than or equal to, this would simplify to a positive 1/4 x, because negative divided by negative, and this would be 24 divided by negative 4 would be negative 6. Okay, so as long as you remember to flip that sign, that is the biggest mistake I always see. People forget. Then you should be good. Let's go ahead and get the other one. Oh wait, other one is in slope-intercept form. Okay, that makes things nice. Let's go ahead and graph them. Okay, I'll graph the top one, which is down here, first. So I'm going to graph this negative 6. 1, 2, 3, 4, 5, 6. There we go. And then my slope is 1 over 4. So I go up 1 over 1, 2, 3, 4. See if we can get one more point. Up 1 over 1, 2, 3, 4. And let's get one more over here. Down 1, left 1, 2, 3, 4 to reverse it. All right, take a look at the sign. This will be a solid line because we do have the solid line under it. Also, if you want to just look at both of them, these are both going to be solid lines to give you a heads up because they both have a solid line under it. So let's go ahead and draw that. Draw my arrows on the ends. And let's go ahead and shade. So y is greater than or equal to the line. So remember, greater than the line means shading everything above the line. So it's going to be all this business over here. Okay, so we'll go ahead and do a little rough shading, something like this. Make sure you get a little bit of shaded area in every region, okay? So I know like this line extends this way, right? Just to show y'all. So it is down here too. You just want it in like a little all over, but lightly so that you can erase later. Okay, let's graph our green line, which is right here. We're starting at the +1 on the y-axis. So I'm gonna make my 1 right here. And then my slope is 2, which if you wanna make a note, 2 slope is 2/1. Okay, +2/1. So up 2, right 1 is how we're gonna go. Keep going with that. Up 2, right 1, up 2, right 1. And then let's reverse it this way. So down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. I land on this point over here. And then it would go like down here off the graph. Okay, so I'm gonna go ahead and draw a solid line through that. Okay, and let's deal with the shading on this one now. Let me change it back to my pink color, and let's look at the sign, which keep in mind, it flips. So if you don't flip your sign, you can see how you'll get the entire answer wrong because you'll shade the wrong part. But it did flip in the end, so we look at that one. Y is greater than or equal to, oh wait, am I looking at the wrong one? I am, sorry, let me look at this one. Almost made that mistake. So we're looking at this equation now. Make sure we graph that right. Up to, yeah, we're good. Okay. This sign was not flipped. This is a less than or equal to. So we will be shading everything, if I highlight the line, less than, aka underneath the line. Now, if you have a hard time deciding, well, which side is underneath it, right? Because you get a little confused. Remember, think of it as a staircase. And if you put a guy on top of this very steep staircase, you can clearly tell that underneath the staircase would be all of this, right? So underneath the line is going to be this whole bottom area here. So let me grab my pink. I'm going to shade all of the bottom area, everything underneath the green line. If you can tell, would also include this region, but I know I'm going to erase it in the end. So you can choose to do it how you want. If you can already tell where they overlap, just darken that area, but I'm going to do it the way I've been doing it. So just looking at this green line, I'm going to shade everything under it. Should be all of this. Let me keep going with it. All of that. All right, now we can clearly tell where the shaded areas overlap, which it is really helpful if you have different colors to do this. It's just tough because you have to erase other parts of it. So all this is going to get erased, and all of this is going to get erased, and you can tell this overlapped part right here is going to be our solution set. So let's see if I can erase some of that quickly. Make this a little bit smaller over here. I hate whenever teachers erase something, but they leave like a tiny little mark, and it just drives me crazy. And I know I'm probably doing that, so I apologize to you all. It's the best I can do without erasing the green line itself. And I'll get some of that. Okay, there's that erased part, and I'll do the same down here under this blue line. Because we can't have anything under the blue line. It has to be above the blue line and also under the green line. Should be exactly that section. Okay, cool. And then we just darkened that. And we're done. Good enough. All right. Ready for the most challenging one? It's not that bad. It's just one little learning part that we probably haven't looked at yet. Okay, let's deal with the top one. Now, this equation is weird, right? Like you actually haven't seen, it's very simple looking, but you haven't seen one like it. Pretend for a second that this is just a regular equal sign. I want to quickly teach you something. x equals -4. If I said graph that line, you'd be like, well, that's not in slope-intercept form because slope-intercept has a y in it. It has y equals mx plus b. And this doesn't look anything like that. Okay, so quick little learning moment right here. These are very, very easy to graph. If you ever have a graph that starts with x equals and it equals just a number, that means those graph your vertical, like straight up and down vertical lines. That's it. And where do you think you graph that vertical line? Well, how about at the number -4 on the x-axis? The fact that it is x equals means it's going to be a straight up and down line because those always hit the x-axis, and it's going to hit it at that number. So locate -4 first. So 1, 2, 3, 4. So here's -4. And now it's not an equal sign, it is a less than, so we do need to do a dotted line on -4. So straight up and down, we're just doing a vertical line. So they're honestly the easiest to graph, but I don't think most of y'all have learned how to graph them, so now you know, and they're very easy. Okay, so that takes care of that one. Let's talk about the shading of it as well. X is less than -4. Well, you don't have above or below a vertical line, but you do have left and right, and that's how you're going to determine it. If it's less than -4, and think of this as a number line. So if this is -4, numbers become bigger this direction, right? So this side would be considered greater than the line. Numbers this way are less than -4. Right? Because you would have like -5, -6, etc. So this side is going to be considered less than. Okay, so x is less than -4 means this whole side is going to be shaded for now. So let's do that. I'm going to just kind of lightly shade this side. All right, and let's go ahead and graph our second one, which is not in slope-intercept form. Let me go ahead and erase some of this. Let's get that thing into slope-intercept form, graph it, shade it, and then boom. Oh, what just happened? Let's do this one. It's easier to work with. Okay. I'm going to erase that as well. Okay, let's work on this guy for a second. So we've got, let's look at just the equation. So obviously we will subtract our 3x from both sides first. I'll just use that one so I don't have to rewrite it, which is going to cancel out here. I'm going to bring down the 2y. I'm going to scoot this over to the far left. Okay, so bringing that over here, bringing everything kind of to the left. 2y is less than or equal. This would be -3x minus 2. We got negatives on both of them, so don't forget that. And there's no flipping of the sign on this one because subtracting a number from both sides is okay. A lot of kids think that you have to flip it then. You only flip it when you're multiplying both sides by a negative or dividing both sides by a negative. That's it. Now here is when we do divide both sides, but we're dividing by a +2, so no flipping of the sign needs to happen. So those will cancel. We get y is less than or equal to, so just stay -3/2x. -2 divided by 2 gives us -1. Okay, let's graph this line and see where we're at. So -1 we graph first. A slope of -3/2. That means I'm going to go down 3. 1, 2, 3, and to the right 2. Always to the right. And again, down 1, 2, 3, right 2. And then the only time I go to the left is when I completely reverse it to get more points this way. So now I'm going to go up 1, 2, 3, and to the left 2. And I keep doing that. 1, 2, 3, left 2 puts me here. 1, 2, 3, left 2 puts me there. This one will be a solid line. It's got the solid line under it. So let's draw that. There we go. And then our shading. Okay, so it is a y is less than or equal to our line. So if we take a look at it, less than means underneath the line, which if you think of it as underneath a staircase, that would be all of this business. So you can clearly tell where the overlapping part is going to happen, right? It's where that meets the blue over here. So let's shade with our pink. Everything underneath the green line would be like all of this, right? All of it, everything underneath the green line. But I know in the end, I only need where the blue and the pink overlap. I erase everything else. So let me do that. Precision eraser. Make this a little bit bigger. Try to erase it the best I can. I'll probably erase these little marks. That's okay. Don't need those. Let me a smaller one if I can detail it. Okay, that's good enough. And then, yeah, I would just darken that area. Let me get my blue. Make this a little bit bigger. And that represents everything that's underneath the green line, but also to the left of the blue line. So hopefully that's making more sense to you guys. It's not the hardest concept, but it does take some practice and it can take some time for sure. Oh, I left some little blue up there, or accidentally made some blue. I gotta get rid of it. Okay, that works. Okay, y'all did it. So hopefully if you made it to the bonus, you can go try some of those bonus practice problems, and then you can watch the practice video if you need any help with that. So nice job, you guys.